Okay, in this video we're going to talk about trigonometry with right triangles. And it's important that you understand we're talking about right triangles because in the future we will do trig with non-right triangles. Okay, so to do this we need to know a few things. You need to know that sine of theta is equal to opposite over hypotenuse, and this may be a review for many of you. Cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. It is vital that you know these in order to be able to do this. Okay, some people have different methods of memorizing this. One of those is to memorize instead SOHCAHTOA, which is spelled like this. So you'd have to make sure you had the spelling right. And these three go together, these three go together, and these three go together. And if you know the letters, then you have sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So however you memorize this, it's very important that you know these. Okay, I have two triangles over here that look the same, but I want to make a very important point. When you have a triangle, you first need to identify your sides, and those sides, the names of them are going to vary based on our angle. So in this triangle, we're going to call this theta, so this is the angle we're using. And in this triangle, we're going to call this angle theta. So it depends on which one I'm using. Now, you'll always identify your right angle, your 90-degree angle, which are these two, and the side across from that, the side opposite that, is always going to be the hypotenuse, and that doesn't change. So it's best to identify that first. And then these two sides that are left will be based on theta. So in this instance, when theta is this angle, this side is opposite. This side touches the angle and is adjacent. But on this triangle, if we look where this angle is, that makes this side opposite. And this side will then be adjacent. But it's best to identify those after you've identified the hypotenuse for your triangle. Okay, now we're going to look at an example. So in this triangle, we are asked to find the length of the specified side, which here is x. And we want to round to the nearest tenth. So what we're going to do is we're going to look at the sides that we're given. The first thing I'm going to do is identify my 90-degree angle, and I'm going to identify my hypotenuse. So x is actually my hypotenuse. Then I need to look at the angle that I'm given. And this side, the other side that we have a number for. I don't have a number over here, so I'm not going to worry about that side. But this side's relationship to this angle is that it is adjacent. And so I have to think which trig function that we had earlier actually has adjacent and hypotenuse in its formula. So that would be cosine of theta is equal to adjacent over hypotenuse. And once you have this down, you're just going to plug in what you're given. So we're given that theta, the angle, is 44 degrees. So cosine of 44 degrees is equal to, adjacent is the side we know, that was 9. And the hypotenuse is x. That's what we want to find. So now I have my formula. I'm just going to solve for x. So to get x out of the denominator here, we actually multiply by x on both sides, which cancels out here. That gives me x times cosine of 44 degrees equals 9. And then I want to get x by itself, so I'm just going to go ahead and divide by the cosine of 44 degrees. I'm going to do that to both sides. That leaves me with x is equal to 9 over the cosine of 44 degrees. And I can actually just type this whole thing into my calculator. You do need to make sure that your calculator is in degree mode because we are in degrees, and then radians we'll talk about in the future. But you need to make sure that your calculator is in degree mode. And then you can just type in 9 divided by cosine of 44 degrees. And since we're rounding to the nearest tenth, you should get 12.5. Okay, so try that with your calculator and make sure that you can get 12.5. Okay, on this example, the first thing I'm going to do is find my 90-degree angle, and I'm going to identify that the side across from it is my hypotenuse. Now, in this case, We don't have a number here or an x, so it's not really important to me, other than the fact that if this is the hypotenuse, these two are not. I'm then going to find my angle, and I'm going to say the side across from it is opposite, and the side that touches it, that's not the hypotenuse, is the adjacent side. Once you identify those, this one has a value and this one has an x, so those are the two we want to use. So think about which trig function has opposite and adjacent in it, and that's tangent. So the tangent of theta is equal to opposite over adjacent. So if you can write that, the rest of it's easy. It's just plugging in, but you need to know your formulas here. So the angle we were given was 48. So tangent of 48 degrees is equal to, opposite is x, that's here, and adjacent is 8. So in this case, I still want to clear the denominator here, so I'm going to multiply both sides by 8. That's going to give me 8 times the tangent of 48 degrees, and x is already by itself in this case, so I can just plug that whole thing into my calculator, again in degree mode, and you should get 8.9. So the length of x is about 8.9 to the nearest tenth. Okay, you take a minute, pause the video, and try this problem. Okay, let's look at this again. Here's my 90-degree angle. The side opposite is my hypotenuse, which happens to be x. This is the angle given. A side across from it is opposite, which is 3. This side would be the adjacent, although we have no value or no variable here, so we don't really need it. So I'm going to be using hypotenuse and opposite, and for that, we're going to have sine of theta equals opposite over hypotenuse. That's the trig function you should have identified. So we're just going to plug in now. Sine of 56 degrees is equal to, opposite was 3, hypotenuse was x. And now we just want to solve for x. So let's multiply both sides by x. We're going to get x times the sine of 56 degrees equals 3. And then I want x by itself, so I can just divide by the sine of 56 degrees. And so we get x is equal to, when you type this whole thing in your calculator, making sure that you're in degree mode, you get 3.6. Okay, take a minute, pause your video, and try this one. Okay, here's my 90-degree angle, so the side across from it is my hypotenuse, which happens to be 11 in this case. This is the angle we're using this time, and so this side opposite it is my opposite side, and this is my adjacent, and this is one of the sides I'm going to want to use along with my hypotenuse. So which trig function has adjacent and hypotenuse in it? That is going to be cosine. Cosine of theta is equal to adjacent over hypotenuse. And so we can plug in now. Cosine of 35 degrees is equal to adjacent over hypotenuse. I can multiply both sides. I get 11 times cosine of 35 degrees is equal to x. And then again, I can just type that whole thing in my calculator, and you should get 9.0 when we round to the nearest tenth. That is the length of x. Okay, we have one more that I'd like for you to pause and try. On this triangle, this is my 90-degree angle, so this side is my hypotenuse. And so here's my angle that we're using, and so the 7 across from it, that's opposite. This is going to be my opposite side. That means this must be my adjacent side. It's touching my angle and it's not the hypotenuse. So I want to use adjacent and opposite. So that is going to be tangent of theta equals opposite over adjacent. And so I can plug in now. Tangent of 27 degrees is equal to opposite, which was 7, over adjacent, which is x. Multiply both sides by x. Gives me x times tangent of 27 degrees equals 7. And then I want to divide by the tangent of 27 degrees. So x equals 7 over the tangent of 27 degrees, and that gets done in your calculator. Again, making sure that you're in degree mode. When you do that and round to the nearest tenth, you should get 13.7.